Okay, welcome to October's virtual JBug. This month we've got Aslak Knutsen talking about the Arquillian project. So Aslak is the project lead for Arquillian as well as the project co-founder. He also wrote the O'Reilly book entitled Continuous Enterprise Development in Java. This month's session is actually a two-parter. So this month we'll be focusing on Arquillian with Aslak speaking. And then next month we have Andrew Rubinger talking about the examples from their book, their O'Reilly book. Also, the other thing I wanted to talk about was something that we tried last month at JavaOne. So we tried to broadcast live all the booth sessions from the JBoss booth. We were a bit concerned that this wouldn't work. So, in particular, we were worried that the internet connection wouldn't hold up. So we had sort of very low publicity around this. But actually, it worked perfectly. There was no problems, the quality was great, so it's definitely something that we'd hope to do in the future, providing the conference allows, of course. You can catch the recordings on our Virtual JBug YouTube channel. There's 11 there in total. Okay, so that's everything I wanted to say. So I'll now hand over to Aslak, who can, if you could introduce yourself and start your presentation, that'd be great.
Hi all. I'm Aslak Knutsen, the technical project lead of the Arquillian project, and I'm in my little developer cave at the moment near Oslo in Norway. It's basically just me and my new spider friend Webster up in the corner here that share office spaces. Yeah, I guess that's mostly about me. So if anyone has any complaints, I'll just start on with the presentation. So greetings, Earthlings, the beginning of it. So we're just going to jump straight into it. Within the Arquillian, oh, sorry, maybe I should share my screen. There we go. That'll be helpful. So, greetings. In the Arquillian universe, we have a couple of physical rules, and we'll go through them before we start anything else. The first one is that a test should be portable across any supported container, meaning that the test case itself should describe its requirements and not the specific target. Rule number 2, tests should be executable from both the IDE and the build tool. The reason for this is so when you're in your IDE and hacking away on code, you should not get out of your flow and have to go to the command line and build your whole application, deploy it, and then see the results of what you've done. But of course, you would need to use the build tool combined with, for instance, Jenkins or a build continuous delivery server, but not necessarily when you're developing the tests. And 3. The platform should extend and integrate with existing test frameworks. There are a lot of testing tools and testing frameworks out there that work splendidly well in their specific areas, but what we seem to be missing is there's nothing to kind of bind them all together and make a coherent platform out of it, and that's what Arquillian attempts to do. So just let's go through the basics so we're all at the same level. Contrary to folklore, Arquillian is not a testing framework. It does not impose any specific test methodology or testing style. In its core, it's a simple event machine that can fire events and can observe events, and that's all the Arquillian core does. Nothing useful on its own. So it's a testing platform. It's middleware for your tests, as opposed to being a test framework in itself. It's built to be modular, extensible, and flexible to handle different types of testing scenarios, different type of target runtimes, and different specification and component models, so to speak. One of the first extensions is the test extension. What that does on top of core is to provide SPIs for test runners, and also provide events into the Arquillian core that follow the typical test framework's lifecycle. That being events like before suite, before class, before test, after, and so on. And other extensions now have the ability to react based on those events. And this is where the test frameworks come in. So, as I said, Arquillian is not a test framework, but it integrates with JUnit, TestNG, Spock, JBehave, Cucumber, and Thucydides. And we're not trying to replace any of them. We're simply providing testing services and middleware support into those given test frameworks. If you were to only use Arquillian core and the test extension, you would have the option to write extensions to Arquillian that work across all of those different frameworks without having to know the nitty-gritty details of how JUnit or TestNG works and how their extension models work. It would just work across all of them. On the other side, it's the container extension. Similar to the test extension, it provides SPIs for interacting with containers and provide events like before start, after start, before deployment, and action events like do deployment, do container start. And the implementations for the container extension has a wide range of support, going from Java EE application servers to servlet engines to bean containers, or completely different things like iOS. So the Arquillian's definition of a container is very broad, and it's getting broader. Basically, it's anything that or potentially could be deployed and undeployed to. If you just use Arquillian core with the container extension, you have a sort of a provisioning tool where you can control the containers and the deployments as you see fit. The next core extension is the container test extension, and that's the one that binds the two different extensions into one. So it listens on one side for the test events and fires off container events. For instance, before suite happens, then a container start event is fired. Before class happens, then a deployment happens. So let's look at the basic test class. We're going to use JUnit as an example, just because it's extremely simple. So without Arquillian, this could be a JUnit test. You have a test class and some method annotated with test, and you do some assertions within that. Since you have no type of container or anything in this environment, you would normally either stub out the bean you have or use some form of mock framework for its dependencies, or if you're just using plain old JUnit, unit level tests where you don't need necessarily any of that at all, if you can isolate them correctly. Now, when you add Arquillian to the mix, what you get is this. In the JUnit integration, Arquillian uses the JUnit's run with annotation to tell JUnit to hand over the execution of the test class to Arquillian. So when Arquillian boots up, it then will then look for this specific method called the deployment method. It creates some form of archive. That's the environment that defines how this test should be run. And then we can reuse the component model or the injection points from the various different component models and inject the live instance back into a test case. And then just continue on as if it was a normal unit test. So let's show you a quick demo of just something running. So we saw in the example code, this is, we're handing over the control to Arquillian. We're defining a deployment. We're defining it by adding some classes and resources. And then we have a test where we're asserting some different states on the result. And since this is integrated with JUnit, we can run it as any other JUnit test. You can see interesting things popping up and things happening, but what is actually going on in the background here? How does it all work? So the first thing you have to do is to set it up, of course. Now, it's not required to use a dependency management system, but it's highly recommended. But Maven, Gradle, or Ant and Ivy would do fine. Not just Arquillian has dependencies, but the containers has dependencies, the extensions has dependencies, and it becomes somewhat a lot to manage if you want to manage it in a pure Ant style script. So the first thing you do in the Maven example would be to depend on the Arquillian BOM, the bill of material. That defines a lot of the different versions of the underlying dependencies and align them into a working stack. Next thing is you need to depend on the actual test framework integration that you want to use. In this case, we're using JUnit. So back to our test case. As you can see, there's nothing in here, as I told you about before. There should be no test case should be runnable on all supported containers. There's nothing here defining that this particular test case should run on JBoss or Glassfish. The only thing the test case defines is that we require some form of web archive with these given classes, and something that in this case supports the add inject annotation. And this is normally where I ask you guys, so where would that be? But since I'm the only speaker here, I'll do both voices. So this could potentially run in a full-blown Java EE application server, being Wildfly, JBoss EAP, Glassfish, WebLogic, WebSphere, or it could run in these smaller CDI Beam containers like Weld or even in theory Spring in this case, depending on how the MyBean is defined. So how does Arquillian know how to or which environment to target? Well, the first thing is we need to select some kind of container, and that is done through the dependency chain again. So as long as there's an adapter on the class path, Arquillian will use that. Now, in this case, we're using the JBoss AS Remote 7 adapter. The container adapters tend to come in 3 different forms. It's the remote adapter, which assumes that there is something up and running somewhere, and we can connect to that without controlling the lifecycle of the container itself. Then there's the managed version of these adapters that still run in a different JVM, but the control of the container lifecycle when the container is started and stopped is also part of the Arquillian test lifecycle. So a managed 99% of the time will be something on your own machine, while a remote could be anywhere in the world, basically, either on your own machine or on a test or staging environment or in the cloud somewhere. And the third option is the embedded version, where the container it started as part of the same JVM as the JUnit test itself, and everything is running locally. So then the test framework and the JUnit, the Arquillian integration starts up, we'll start or connect to that container depending on the adapter. We'll come into the packaging phase, which is where the deployment method comes in. At this level, you have access to the local resources from the run environment, that being either the build tool or the IDE. And to help us out there, we have a project called ShrinkWrap. It comes in a couple of different varieties. One is we call the ShrinkWrap archives, or the original ShrinkWrap, which is a fluid API to construct different virtual archives, or virtual archive structures, rather. So based on the available resources you have on the client side, you can add classes or packages or URLs or any feasible resource you want to put into an archive. And you can create structure based on, it could be Java archive, it could be web archive, enterprise archive, resource adapters, OSGI bundles, Android packages, and mix and match them however you see fit. In a recent study shown by Zero Turnaround was that the majority of time spent on a project is not in the deployment phase, as one might think. It's actually in the build phase. In a large application, building the whole thing from scratch can take anything from, well, if it's a large one, anything from half an hour to an hour. And that's where the beauty of ShrinkWrap comes in. It relies on the incremental compilation that's available in the IDE and can bypass the whole build phase entirely. So as soon as you have defined the archive and added a class, it will load the class as it was in your local environment. And from the IDE, as you change a class, the IDE will incrementally compile that class, and as soon as that's done, it's available for ShrinkWrap to do without running the whole build again. The next part of ShrinkWrap would be ShrinkWrap Resolver.
I'd like to just interrupt you a second.
Yeah.
Before you go on, so we have a question. So the question, so what's the difference between the embedded and the remote container dependency?
The difference would be that a remote would connect to another JVM, basically, and the embedded would start up the container as part of the same JVM as where JUnit, or yeah, in our case here, where JUnit would be starting, if that makes sense.
Sort of. So I guess the next question is, what's the difference between embedded and managed?
The difference between embedded and managed is the same. Managed would start it up in a different JVM, but you can control the start and stop of it. While embedded, you can still control the start and stop of it, but it's within the same JVM as the test case.
Okay, and then with embedded, does the application server binary get pulled down from Maven, or do you need to have it already installed on your development box?
Which one was that?
Embedded.
That depends on the adapter, actually. It depends on the implementation. So some do and some don't. In the case of the Wildfly embedded mode, you have to point it to a JBoss home to tell it what to start. In the Tommy example, all the dependencies are there and will start up. Same with the Glassfish one.
Okay.
So it depends.
I think that answers the question, but I will check.
All right.
You can carry on. Thanks.
All right. So yeah, the next thing is the ShrinkWrap Resolver, and what that allows you to do is to interact with the Maven repositories or with the Maven process itself. In the later version, also interact with Gradle as a build tool. So in this example we have here, we're loading metadata from the POM file of the current module that we're in, which means it will resolve things like the repository information. It will find all the versions of the given dependencies as they're defined in the POM, and we have an option to resolve either with or without a version. So we can say use whatever version was in the POM or use a specific one. With or without transitive dependencies, as files or as archives, or however you want to resolve them. And those you can add then directly into the ShrinkWrap archives and bundle them along with your deployment. Either it's other testing tools that you need, or it could be your own dependencies or some other framework that you're using. And then the last ShrinkWrap one is the ShrinkWrap descriptors. The descriptors are similar to how the ShrinkWrap archives work, but instead of creating virtualized structures of the archive, this creates virtual structures for the content of a given file. Most of them are targeted around the JavaE descriptor files. So you have your web app descriptors, your EJB descriptors, your application descriptors, all representing the different EJB jar XML, application XML, and so on. Useful if you have a test case of, let's say, a servlet that needs to be tested in multiple different environments, with or without authentication, for instance, or other settings. So instead of having multiple web XML files scattered around in your test folder on disk, you can easily just define it on the go as part of the deployment method and say that this is the environment that we want to run this specific test class in. So when it's done with the packaging and it then deploys, potentially intercepts the deployment and wraps Arquillian around the whole deployment as well, and then goes over to the container side. Then when we're in the container, that's when the run of the test methods happen. At that point, you have access to all the resources that the container provides. That being JMS queues, connection factories, data sources, EJBs, CDI components, and whatnot. It behaves and feels like any of the other JavaE component models, or in case of OSGI or Android, for instance, you will have access to the bundles and so on. And then it returns all the test results through the test runner, being JUnit or TestNG and so on, and goes up the same chain and is reported in the same fashion as the test framework normally would report it. So there's no difference when you're running a test that runs in a remote JVM versus one that runs in the same JVM as far as the test framework is concerned. So you'll still have your green bar in the IDE, you'll still have your Maven Surefire reports, etc. And as a last step, it undeploys the test archive and stops or disconnects from the container. So sort of a cleanup phase. Then there's a couple of different run modes, different ways of running the tests, or controlling Arquillian for that matter. The first one is the default one, which is running in container and having the access to all the local container resources. Excellent for testing EJBs, for instance, which are not exposed remotely, or not having a need to expose them remotely because you're in the same environment as them. CDI beans, for instance, and all of those internal container resources. The second one is the run as client, as we call it, which is basically where Arquillian only deploys the deployment for you, and you're running the test method is actually running in the in the same JVM as JUnit is running. And at that point, you don't have access to any of the internals of the container, but you do have access to all the remote endpoints. So useful for HTML, web application, JXRS, web services, WebSockets, and all of those types of remote things that already have a clear interface defined, or remote interface defined, rather. And then there's the mix of the two, which is Arquillian Warp, where when you have one remote call, let's say a browser request, you can intercept that on the container side and do things, for instance, before or after servlet, or within the different JSF life cycles. I mean, before or after render, for instance. You can either assert some state or set up some state if you wanted to. So with that, I think we can jump over to some more demos. Let's first look at just this simple run as client example. This is a REST service that is being called. We have a dummy application here that's a conference application. It has a JPA backed conference repository. It has a JXRS service and a JSF page. Nothing fancy at all. You'll see much more fancy examples in the talk with Andrew next month. So we have the, as we've seen before, the run with Arquillian. We have our deployment that's defined to be testable false, meaning it's going to be running on the client side. We have our app defined, adding some classes, adding some files, adding a CDI, and the base here we should see we're adding the backend for the conference as well, which is JPA Web Persistence XML. I just look at the repository just for the sake of it, but it's just a stateless AGB that wraps the entity manager essentially. So in this case, we're going to see, well, on another note, we have a Wildfly container up and running on the side here, and we're going to be running these tests against that container. So one of the interesting things to note here is that since Arquillian has the control over both the container and the deployment, it also knows things about where things are deployed. So we can inject back, using the Arquillian resource, things like the base URL for our application. In this case, that should basically give us something like HTTP :/localhost.8080/ and whatever the deployment name of our archive is. As we saw before, you simply do run as JUnit test. You should see it connect, it should deploy, and there we go. You probably can't see much what's going on in this console window, but you can trust me that it's happening something. We have the conference REST endpoint, another stateless session that's being deployed. We have the conference repository, another stateless session being deployed. And we have Hibernate setting up the tables and inserting some data here somewhere. There we go. Inserting, selecting them, and going through the whole JXRS stack, basically down to the database and back. That's pure Arquillian core stuff. Let's look at the other pure Arquillian core. It would be, again, we have the run with, the deployment, but in this case we want to run in container. So since we're now in the container, we can inject things like the conference repository directly, which is a stateless local session bean by default. And of course, we also have access to the user transaction. In this test case, we're going to simply make sure that when we store something in one transaction, when we get it in a different transaction, those data are actually the same and what we expected them to be. Just some small helpers and a callable within a transaction, so nothing too fancy. And again, of course, run with JUnit test. Now, having to deal with a lot of the JPA type of comparison, or if you're just doing data operations and you're verified like here, I mean, here we're actually verifying the transactional behavior of the repository just as much as we're verifying the different data that is being stored in and retrieved. If you're looking for a cleaner way of doing just the storage or your operation on data from a database, we have the Arquillian persistent extension. What that does is it adds up things like, if you look at the second test first, as the annotation says, using dataset, which means that before this test is being called, the persistent extension will intercept it and insert the data that is defined as in this dataset into the database. In this case, it's a YAML definition. You can also have them in XML, JSON, in Excel, and a few other formats that I don't remember. Here we have three different tables that we're inserting data into: the conference, the user, and the join table between them. So we're just testing that when we've inserted when our repository is capable of getting one specific item or one specific conference out of the database with a given name. And when the test is done, it's going to clean up the tables that have been in use. So it knows that we use the user conference and the conference user table, and those will be cleaned as soon as the test is done. On this side, you can also say, when the test is done doing something, and verify that the database looks like this. So in this case, we're actually inserting the data. We're creating a given conference and adding a speaker and storing it in the database. And we can have the option to exclude things like the dynamic IDs or times, for instance, that are not necessarily directly relevant to or easy to assert any given state on. So there's one where the database is set up before the test is executed, and there's one that verifies after it's executed. And this again just runs as a normal JUnit test. We'll see it deploy and execute its queries. Voila, green bar.
Can I interrupt you, Aslak?
Yeah.
So we have another question, and that is, can Arquillian work with other testing frameworks like Cucumber?
Yes. That was slide number, what, 4, 5? Arquillian works with JUnit, TestNG, Spock, JBehave, Cucumber. The Cucumber integration is called Cukes in Space. And 2CDs are the ones that we know so far. So yes, absolutely.
So Cucumber, I don't know what Cucumber is, so what's Cucumber?
Cucumber is a BDD style testing framework.
Okay.
Yeah.
So Cucumber it's a framework in the same way that JUnit is.
Yes.
Right. Okay, I see.
Same but different. Yeah.
Yeah. Okay. So in the same way that you support JUnit, you also support Cucumber and a number of other frameworks.
Right.
Excellent.
Yeah, and basically, if there's a need for to integrate with some other framework, the integration with Arquillian is fairly easy. You just to call in the correct events at given times, and Arquillian will do what it's supposed to do. So it's easy to get up other ones if anyone has any specific needs as well.
Great. Are you finding that people in the community are starting to integrate with different testing frameworks, or is this something that you've been doing in the Arquillian project?
No, most of them are community-driven, actually.
Excellent.
Most of Arquillian in general is, so yeah.
That's good.
Drew, anything more on this one? No, I think that was it. So, yeah, we saw it run and everything, yeah. Then we have Arquillian Drone, which is the extension for handling anything that's WebDriver Selenium related. Meaning the only thing we need to do is basically say inject the WebDriver, and we externalize the configuration of what type of driver this is, and you also have the option to use multiple drivers of different types if you have some weird scenario where you need to test how Firefox interacts with the server side and IDE as a different client, for instance, or just multiple different sessions of the same browser. So in this case, it's just we're hitting a JSF page. We'll see, and we saw this was the first demo that we ran as well. We'll see the browser pop up. Of course, you can use pretty much all the Selenium drivers that are available. So you could as well use HTML unit or Phantom.js to do have it more for the build server, where you don't necessarily have a full UI. But this, as far as the assertions go and so on, is straight up WebDriver Selenium expressions. So again, we run as this time we can actually do a debug just to see if we can kind of step through the test as well while we're interacting with the browser. Touch up and stop there, and there we're in debug mode. So now if we see where we're coming in from, the standard JUnit runner in Eclipse, and we haven't even hit the page yet. So what we're doing here is creating an object on the client side. We're just inserting that data into the different fields, and we're saving it and then verifying that the URL has a specific value in it. Excuse me. So that's drone. Let's look at the third run mode that we saw. Let's add a couple of other ones on top of that just to make the last finale, interesting. So let's activate another profile as well, recorder. This is a warp test where we can intercept client-side calls on the container side and do things while it's happening. And it's also using Arquillian Graphene, which is let's call it an enhancement to the Selenium WebDriver APIs. So on Selenium you have the page objects pattern, which is basically wrapping a lot of the expressions for how to get CSS classes and IDs, etc., out of the response that we get from the HTML page into an object, so we can have a Java API on top of it. Now, Graphene adds a couple of interesting properties on top of that. So you have the location You can basically specify where this page of ours is supposed to be, and you can inject subcomponents as well, being the page fragments. If you have reusable components, for instance, you can then easily inject them into different pages, that being the menu bar or the login buttons and that kind of thing. So we're saying that on this page we're going to find some element that's create and wrap element that has a ID of create, wrap that in a conference form object. So this is then the root of the element is then the create element. Within that root element, find IDs of create conference name, create conference location, and all the different fields. Then can wrap around in our own little Java API and say to have these expressions localized to the Java version of the object, as opposed to having them all scattered around in the test classes themselves. So what's happening here now is that when we're deploying, we're injecting the URL, we're starting up a web driver instance. We're actually, sorry. We're injecting the initial page, which is where where Graphene will intercept the test method and initialize the conference page on the given location for us. And from there we can get the form, we can set all the values. And then comes the interesting mixed mode bit, where when we're doing a form submit on the client side, we want to verify on the server side that that something happened. So we are creating a object on the client side, which is our conference, which is just generating some random conference. We're then passing along to our verify conference inspection object as a member, and that's being intercepted on the server side when our form submit hits. In this case, we're doing it in the after servlet event. So when that happens, we're going to inject the conference repository after our servlet is done and our form has been submitted on the server side. We inject the conference repository and verify that the data that's been stored in the database is actually the same as what we expected it to be stored, and actually stored, as opposed to just a web page returning and pretending that things are all right. And we're going to run this with another Arquillian extension, which is the Arquillian reporter, where we can add report messages like this to give it more context to the different test methods and the test classes. We'll see the output of that afterwards. But still, we're just running it as JUnit test. You should see it deploy. The browser startup. And voila. Now, what the Arquillian Reporter extension has done is to record the report for us. What happened and which tests were ran under which environment, under which configuration, and also with integration with Graphene, taking screenshots of what was happening in the browser. So the report looks like this. This was just one simple test case, though, so it's not very full. But we were using Firefox, we were using a given data source. We had the screenshotter to take screenshots both before and after. The suite started then and then, took so and so long, and the test passed. And it also gives us the screenshots of what happened before the test, or the state before the test, and the state after the test. And similarly, you can configure it to only record if something failed, for instance. So you can easily see in a report on your build server later that what went wrong and how the application failed. And hopefully you don't have to dig through too much of code to figure out that, oh, that's the error. And we're running semi-short on time, so I'll show you next the easiest way to get started with Arquillian is using basically downloading JBoss tools and using JBoss Forge to get started. So you press Control 4 and Forge pops up. We want to create a new project, call it VJBug, Java web application. We are using Maven, finished. And then we can use then Forge again. We want to set up Arquillian. We want to use 1.1 final. We want to use JUnit in 4.1.1. We want to use Wildfly Remote 8. Happen to have a 8.0.0 final running, and finish. We want to activate the profile Arquillian's created. It's basically now set up your POM file as we described in the slides earlier with the Arquillian BOM, the JUnit integration, JUnit itself, and a profile for the Wildfly remote adapter. Plus added an Arquillian XML file to define the container itself. That's all the setup, and then going on further using tools, you can say you want to create an Arquillian test case. You want to create a simple test case. You want to generate a deployment, finish, and there you go. You have a CDI enabled web archive as an example, and something that fails. Now we can do as we've done before, run as JUnit test. This time it should fail, just to see that the full integration works, not yet implemented. And we can do assert true, assert true, oops, true. Silly ID. And again, run it again, and we should have a green bar. Green bar. All right. So, if you want to learn more about Arquillian, one of the best resources we have are the Arquillian guides. On arquillian.org, you'll find getting started guides, how to set up Arquillian, how to use Forge, how to create the deployable archives with ShrinkWrap, testing JPA, functional with Rome, etc., etc. That's the #1 resource, and of course the Arquillian forums. And with that, I think I'm done, and handing it back over to you, Paul.
Thank you, Aslak. I'm just going to ask in the IRC room if you have any specific questions. So one of the things that people were a bit confused about is so back on the issue of the difference between the remote, the managed, and the embedded mode container. So I think they kind of understood the differences, but they weren't quite sure what the practical use cases were for each of those. You know, so if you could give a good example of when you would use each one, that would be good.
Right. So the practical use case for embedded tends to be, it might be easier to set up than the managed ones. You don't have to point to anything. That's not 100% true because it depends on the container adapter implementation, but it's true for Tommy, it's true for Glassfish. The managed one is something you want to use typically for the build server, because you don't want the penalty of starting and stopping the container every time you run a single test in your IDE. You might do it if you really want to, or if you really have a need to test something very specific during startup or that kind of thing. But in general, managed is something that's that you hand over to the build server, and that the build server grind away when it runs its tests. The remote one is useful for development mostly, or in combination with other extensions, like if you start up nodes elsewhere and control them differently than what you do with Arquillian, you just want to connect to that specific host. It's useful for development because you can start up an app server during the day or during the morning, and then you can just sit and deploy as you write your test cases, and without having to get the penalty of the start and stop of that container on every test run. Then you only have the penalty of the deployment happening.
Okay, yeah, that makes sense. That's good. Okay, I'm just looking to see if there's any other questions. So there's also been some discussion about using databases, so using real data in databases. So maybe you could talk a little bit more about how the database extensions work with Arquillian, and how do you manage kind of populating the databases with test data before the test runs, and then presumably tidying it up after the test is finished. And does that work on, does that go onto real databases, or how does it work, or does it use its own embedded database?
Well, the Arquillian persistent extension works basically by feeding it a data set, either to match or to insert. Then under the hood, it will use dbunit to actually do the heavy lifting. What you feed it with is a data source. So that data source could be to an embedded database like H2, or to an Oracle database running on the same machine or somewhere else. That's depending on the configuration of the app server or the container, really. But of course, you're fairly soon will realize that you can't really parallelize these necessarily too much, because you will be inserting the same data. Depends on if you have auto IDs and so on. So you can't necessarily be running two of the same tests in parallel, because they will be clashing with the data, or how they're cleaning up the different data sets. We don't have any perfect solution for that yet, but we're trying to look at generating the data differently, and potentially on some databases you could, for instance, use one schema per test, for instance, to kind of separate them out into different containers, or not containers, silos.
Okay, so how to explain this? The data that you inject into the database, one way of representing that is in a YAML file, correct?
Mm-hmm.
So you basically need to, as a developer, you need to keep the schema that you use in the YAML file. That needs to match what the schema that's being used in production.
Right.
Is there any way of making that less error prone, or is it just something that you need to maintain and make sure that there's no mismatch between the two?
I know there's been talk about looking into integrating the Arquillian persistent extension with the things like liquid base, kind of like the schema evolve type of thing, and potentially have like a first time setup where you could export the data and kind of get more of the automated process around it. But as far as I know, there's nothing that's built yet around that specific issue.
Okay. I think that answers the questions around that. The next question is, can I use the remote container in the build server?
Absolutely. There's nothing stopping you from doing that. The problem you might run into would be that if you're unlucky, the container will eventually run out of perf-gem space or that kind of issues. But per se, there's nothing stopping you from doing that.
I think that's what I've done in CI in the past. I don't know if I was doing it for the right reasons, but I'm pretty sure we've definitely done that, and it worked fine. I can't quite remember why we did it. I can't think of a good reason why we did it, but we did. So.
No, I mean, potentially you would have in a CI environment, you would be running tests against a specific test environment, right? So that could be a different server somewhere that you're actually targeting that is not started as part of the CI build itself. So
absolutely.
Heard of.
I can understand why other people would do it. I just can't remember why we did it. I don't think we had a good reason to do it that way. I think maybe we were just naive at the time. I'm not sure. But yeah, it worked. So.
Right.
Okay, so let me see if there's any more questions. Doesn't look like it. Was there anything else you wanted to say, Aslak? Just while we're waiting for some questions, I don't know if there's anything you didn't have time to cover that you would have liked to have done.
No, it just end up with saying that Arquillian is a Apache License 2 project. It's hosted on GitHub under the Arquillian organization. You'll find most of the extensions there, not all of them, but some. The main website is arquillian.org, and we're on Google Plus under the name Arquillian. We're on Twitter under Arquillian_org. And yeah, come step by on the forums if you want to say hi.
Excellent. Oh, one more question. Oh, okay, I think it is. Okay, so I think what they're just saying that they're keeping the schemas in sync from your tests and your actual database. They're just saying that they see it as a real use case to these guys. So I think it's just some feedback that it's worth thinking about.
Yeah, absolutely.
It's things that people care about, it seems.
Yeah, that is true.
Yeah. So okay. Okay, so I think looks like. Oh, hang on. Hang on. I'm not quite sure if this is a question. Oh, it was a comment. It wasn't a question. Okay.
All right.
Okay, so yeah, just one other thing I wanted to say was, yeah, just if you have any requests for anything that you would like the virtual JBook would like us to present on, or if you have any ideas, or if you have any feedback, then please get in touch with us through the meetup group. And also, if you want to look at all our past content, then we have the virtual JBook channel on YouTube, which is where you're watching this video at the moment. So you can take a look at our other sessions. And in particular, you might find the booth sessions interesting from JavaOne. So we've got 11 booth sessions there, which I encourage you to take a look at. I'll do one final check of IRC, and then we'll close. Okay, looks like we're done. Well, thank you very much, Aslak.
You're welcome.
It was very interesting. Thanks for all those that attended. Bye-bye.